students, welcome to Matrix classes. Today we will discuss about triangles and basic properties of triangles. Triangle is defined as a closed figure formed by three sides. You can also call it as a three-sided polygon. Here you can see in the figure ABC is a triangle. A triangle has three vertices. So here I can say A, B, C are vertices. A triangle will have three sides. They are AB, BC and CA. You can represent sides of a triangle by using the small letters also. The side opposite to vertex A is indicated as small a. The side opposite to vertex B is indicated as small b. And the side opposite to vertex C is indicated as small c. Okay, now we will discuss exterior and interior angles of a triangle. How to draw exterior and interior angles of a triangle. Yeah, so here in this figure, triangle ABC, angle 1, angle 2, angle 3 are interior angles. When you extend that AB, BC and CA, the angles formed are called exterior angles. Suppose here I will name the exterior angle as 4. Here I will name this exterior angle as 5. And this one I will name as 6. Now for angle 4, exterior angle 2, angle 3 are opposite interior angles. Opposite interior angles. Similarly, for angle 5, you can say angle 1 and angle 3 are opposite interior angles. For angle 6, you can say angle 1 and angle 2 are opposite interior angles. Okay, so this is how you can draw interior and exterior angles. Next, we will discuss classification of triangles, how you name them. Okay, based on sides and based on angles. Here you can see classification of triangles based on sides. The first category is scalene triangle. The second one is isosceles triangle. And the third one is equilateral triangle. In scalene triangle, all sides are different. So you can write AB is not equal to BC is not equal to CA. So you can say all the angles are also different. Angle A is not equals to angle B is not equals to angle C. Suppose if I write these sides as 5 centimeters, 6 centimeters and 7 centimeters, I can call this triangle as scalene triangle as all the sides are different. The next category is isosceles triangle. In isosceles triangle, two sides are equal. Here I will assume AB is equals to AC. If AB is equal to AC, this one is called vertical angle. Angle B and angle C are equal and we call them as base angles. We name them as base angles. Okay, so we can write angle B equals to angle C. Next, equilateral triangle. In equilateral triangle, all the sides are equal. AB equal to AC equal to BC. And all the angles are also equal. We can write AB is equal to BC is equal to CA. And all the angles are equal. And each angle will be equal to 60 degrees. Okay. So this is classification of triangles based on sides. Skeleton triangle, all sides are different. Isosceles triangle, two sides are equal. Okay. And that point where they meet, where the equal sides are meeting is called vertical angle. Other two angles are called base angles. This is very important. Just remember which are called as base angles. Next one, equilateral triangle. All the sides are equal. So is all the angles. And each angle is equals to 60 degrees. Now, we will discuss classification of triangles based on angles. Here, you can see classification of triangles based on angles. The first category is acute triangle. The next one is right triangle or right angle triangle. And the third one is obtuse triangle. Okay. So in acute triangle or acute angle triangle, all angles are less than 90 degrees. Suppose if I take this, suppose this is 60, 70, 50. You can call this triangle as acute angle triangle. Okay. All the angles must be less than 90 degrees. Here, how to identify the acute triangle? Okay, we have a condition how you can identify. Based on the sides also you can identify acute triangle. If angles are given, you will check the angles, and if all the angles are less than 90 degrees, you can call it as acute triangle. Suppose if sides are given, how you can identify whether it is acute triangle or not? Okay, suppose if AC is the biggest, AC is the biggest side, then AC square less than AB square plus BC square, we can say the triangle is acute. Triangle must be acute triangle. Okay. So next, right triangle. Right triangle, one angle must be equal to 90 degrees. Okay, that suppose here B is 90 degrees and the side opposite to right angle is called as hypotenuse. And other two sides we can call them as legs of the right angle triangle. Okay, the side opposite to the right angle is called as hypotenuse. Hypotenuse is the biggest side in right angle triangle. Okay, and how to identify a right angle triangle based on the sides? We can use a famous Pythagoras theorem, that is AC square is equals to AB square plus BC square. This is how you identify a right triangle if sides are given. If this criteria is satisfied, then you can say it is right triangle. Here AC is the hypotenuse, which is the biggest side in the triangle. Next, coming to obtuse triangle. Okay, so here this angle, one angle must be more than 90 degrees. Suppose if I assume this angle as 120 degrees, so this one I can take some 40 degrees and this one as 20 degrees. You can name this as obtuse triangle. Okay, so in obtuse triangle, AC square, obviously AC is the biggest side. AC square will be greater than AB square plus BC square. So, if sides are given, to identify what kind of triangle, means acute or right angle triangle or obtuse triangle, first you have to identify the biggest side. So if AC square is less than AB square plus BC square, We can call it as acute. AC square is equal to AB square plus BC square. It is right triangle. And AC square is greater than AB square plus BC square. Then it is obtuse triangle. All these conditions are written assuming that AC is the biggest side. Okay. So that is the classification of triangles based on angles and based on sides. Now we will discuss angle sum property in the triangle. Angle sum property in a triangle says that sum of three interior angles of a triangle must be equal to 180 degrees. If you add interior angles of any triangle, the sum should be 180 degrees. Otherwise, it will not be a triangle. Okay. So, let us see how we can prove it. Let us take a triangle ABC. I will name the angles of the triangle as 1, 2, 3. Our job is to prove angle 1 plus angle 2 plus angle 3 is 180 degrees. Now what I will do is, I will draw one line through A which is parallel to BC. Through A, I will draw a line called as DE and it is parallel to BC. I will name these angles as 4 and 5. Now DE is parallel to BC as for the construction. So I can write angle 4 equals to angle 3. Angle 4 equals to angle 3. You can see they are alternate angles as these two lines are parallel. AC is transversal. So 4 and 3 are alternate angles. I am writing here. Alternate angles. Similarly, I can write angle 5 equals to angle 2. Same reason. Alternate angles. We know that angle 1 plus angle 5 plus angle 4 is 180 degrees. Sum of angles on one side of a straight line will be equals to 180 degrees. Now angle 5 I can write angle 2 because those two are equal. Angle 1 is same as angle 1. Angle 4 I will replace with angle 3. So this is 180 degrees. Now you can see sum of three angles of a triangle is 180 degrees. Okay. Now we'll see one small application. Suppose in a triangle, two angles are given. Suppose this is 40 degrees, this is 70 degrees. Find the missing angle. So using this property, I can write x plus 40 plus 70 must be equal to 180 degrees. So x plus 110 degrees must be equal to 180 degrees. So x will be equals to 70 degrees. Okay. Let us see one more application. Suppose angles of a triangle, angles are given. Three angles are given. Suppose 40 degrees. Let me change the color. Yeah. So question number 2, you can say 50 degrees and 70 degrees and 80 degrees are given. Will they represent angles of a triangle? That's the question. Will they represent angles of a triangle? For that, what I should do? Sum of angles. Sum of angles is 50 plus 70 plus 80. That is 120 plus 80, which is equals to 200 degrees. So they are not angles of a triangle. Okay. Yes, students, I hope you have enjoyed this class. In the next video, we will discuss exterior angle property and how to calculate the angle between internal bisectors, external bisector, and one internal bisector and one external bisector. And we will discuss some of the applications of angle sum property and exterior angle property. Okay, thank you.